Two parallel planes, pi1 and pi2, have their equations given as shown here, where n is ABC. So, if we consider the origin here, one of the planes would be here and the other one would be here. And the reason I know they're on different sides is because this is positive and this is negative. So, this is the origin O. Now, we know that we can get the distance between the origin and the plane if we know some point over here on the plane. Let's call it A, and then that's the perpendicular distance there. We know, let's just put the normal here as well. We know that the distance here is equal to mod A cos theta. But A dot n is mod A mod n cos theta. So comparing the two, we can see that D is equal to A dot n divided by mod A. Correction, mod n. Therefore, this distance here is 11 over the square root of a squared plus b squared plus c squared. And the distance here is 4 over the square root of a squared plus b squared plus c squared, because of course we know that r dot n is equal to a dot n. So in the first case that's 11, in the second case that's negative 4. And therefore the distance is just going to be those two added up. 11 over the square root of a squared plus b squared plus c squared plus 4 over the square root of a squared plus b squared plus c squared, which is equal to 15 over the square root of a squared plus b squared plus c squared. Now, if you look at their answers, there's a hell of a lot more work there than I've done. And that's because often the method for finding the distance between a point and a plane is very different to what I do. I do it exactly this way by constructing parallel planes. So in order to make sure I got the 4 marks, I think that I would explain what I've said over here very carefully.